assessment for me, okay?
Yeah, and Gavin.
How goes, guys? Ready to go?
Yeah.
Well, welcome back. Look who showed up. Where's your partner in crime at? You don't know? Go ahead and fire up everybody. Okay, we'll wait for everybody else to get in here. We're going to go over these as soon as everybody gets back. And we are recording. Okay?
Well, I don't have anybody in my group.
That's okay. You're going to share with the other group today. Noah and Natalie and Ryan. Okay? Mm-hmm. Jack me with you guys.
Are we doing a review game?
No, we got to get the rest of our notes.
Do we have a test on Friday?
We do.
Why?
Because I think they're going to be ready for it.
Well, no one's here, so they're not going to be ready for it.
They will want to watch this video.
Sophie, where were you in Spanish?
Ken was not.
She just answered that.
But he was right wasn't in
Just
here.
came in. Oh, my bad.
That's okay. Ryan just came in. All right. Let's get everybody else in here so we can get going. Go ahead and fire up everybody. Okay? When you talk about this kind of problem, you might see those again. All right, well, we're going to go ahead and get going. Hopefully, Reagan and Maureen will be back here in just a hot minute. Okay? All right, so for these problems right here, what you have to do is determine what values of A, M, and N give you the desired result. Okay? So for example, on number 1 here, okay, so for number 1, A has to be what number? Michael? What?
7.
Yeah, A has to be 7. Okay? Because these properties only apply when the bases are the same. So in order for this to work out right, A has to be 7. So you answer 7 to the 9th power. Okay? Useful. Now, this is just testing your knowledge of the properties. So, when you multiply bases, you have the exponents, right? So, you get a combination, when you add M and N, you get 9. Any combination will give you full credit. Give me a combination. Michael?
7, 0, that work?
7 and 0 won't work because he has the total 9. Your exponent's 9.
Oh, sorry, 9, 0.
9 and 0, that works. Noah? 6 and 3. Any combination works. 1 and 8, 2 and 7, 3 and 6, 4 and 5. Okay? If you want to get fancy, -1 and 10. Okay? If you want to get really, really fancy, 191. No, I'm sorry. -100 and -91 and 100. Sorry about that. I was thinking about the problem. So, okay, all you have to do to get full credit on these is give me a combination that works. On number 2, what does A have to be? A has to be 14, right? Okay. What does M have to be? You want this to total 14 to the 6th power, okay? So what does M have to be in order to get that to equal that expression? A is 14, Natalie. M is what?
Negative.
Well, it's already negative. This is the negative M power. So it's just positive. But you need to watch out for that. If I don't put the negative sign there for you already, you need to make sure you remember to do that yourself. Okay? Very good. Number 3, a to the m divided by n to the n. has to equal 9 over the 4th. Okay? So A is what, everybody? Tell me all in one voice. 9. Give me a combination that works. Okay? What do you do with M&N this time? Okay?
You can have
Oh, thank you kindly.
that.
9 and 5. 9 minus 5 is 4. Perfect. Anything else? Anything? 6 and 2. Any combination that subtracts the 4 gives you a correct answer. Okay? You're subtracting the exponents when you divide faces, right? So any combination that subtracts the positive 4 gives you a correct answer. For the last one, how do you get 20? First of all, what's A? A is 12. How do you get 20? Okay? Reagan, how do you get 20 on this one? What do you have to do? Yes, 10 times 2. Very good. We need to multiply them, right? Okay. 1 times 20, 10 times 2, Michael. 5 times 4, any order. Okay. Negative 2 times negative 10, so on and so on and so on. Make it easy on yourself. Okay? Make it easy on yourself on the assessment. I'm telling you right now that you're going to see problems like on the assessment. Okay? No surprises, okay? And you can practice those tomorrow for your assignment. All right, let's go to our notes. And then I want to follow up with a little bit on our assignments for tomorrow. Okay? Because I got 2 for you because I'm moving up your assessment to Friday instead of it being next Tuesday. The reason why I'm doing that is because the bulk of your assignments over the exponent rules, you've already gone over those a lot and had a lot of practice over those. So those should be in pretty good shape. So when you take on the little bit here about with the radical expressions, you should probably be able to be prepared for this tomorrow and be ready to go on Friday. Okay? We got to get going here on some stuff. We're a little behind everybody else. In order to get where we be at the end of spring break, before spring break, we got to pick up the pace just a little bit. Okay? So we're going to try to knock that out a little bit today. So in our notes, let's find what we were looking for. Here we go. And this is yours. All right. So we talked about this on Monday, right? Talked about this on Monday, how you cannot take the square root of a negative number. That's not a real solution. Okay? That number is not defined in the real numbers. It's something else. You'll learn about that in Algebra 2. So today, how do we take the square roots of variables? Okay, that's what we're going to discuss today. Look at these 2 examples here. Okay, A and B. Okay, let's discuss for a second. What do you think the square root of x squared is? Why? Okay. What do you think the square root of x squared is, right?
Technically, square root of x squared.
That's
I'm
okay.
thinking it would have been x1, but then I realized you can't really do 1.
Why not?
Because 1 times 1 just equals 1. Exactly.
Well, wait a minute, though.
Oh, no, it would be 1 because you're adding the multiplications.
Okay.
X to 1.
Okay. Okay. So you're going to go with x then? All right. Brian thinks it's x. The square root of x squared is x. Who agrees with Brian? Okay. You'd be correct because x times itself is x squared. Okay. Very good. Now, think about b for a second. What is the square root of x to the 4th power? See if you can follow a pattern here. Okay. Noah? Ryan? Or Noah thinks it's x squared. What do you guys think?
X.
What times itself is x to the 4th power? X squared. X squared times x squared is x to the 4th power. Okay? So here's a little thing I think we need to keep in mind. Okay? So we can use a pattern now. What's the square root of x to the 6th power? The square root of x to the 6th power. Think about a pattern here. Okay? Marina. X to the 3rd. X cubed. Right. How about the square root of x to the 8th power? Natalie? X to the 4th. Okay? Are you guys caught on to something here? If the exponent on your variable is even, okay, it's a perfect square number, or perfect square term, we should say. Okay? So it has a square root. It has a good square root. Okay? There's not going to be anything left over in a radical. The square root of x to the 10th is x to the 5th. The square root of x to the 20th is x to the 10th. Everybody see how that works? Okay. So that's something for you guys to consider. Now I'm going to show you something else here now. All right? Check this out. C and D. Okay? Work with your groups for just a hot minute here and see if you can figure out an answer to C. Okay? Okay. Jack, you work with the green group. So you work with the other group. No, we're not going to work with decimals. There's no need to. Okay? Well, that's what you guys need to talk about right now. Okay? What would you do? Okay? What would you do?
That's what I'm saying.
I can't
You
remember
could do
things
x
anymore.
times x to the second, and you would be adding it, and it would be x to the third.
Yeah.
Or you could go either way. You could do x,
No,
or
but
you could do x to
so
the
if we
10th,
like a
divided
radical,
by
you would have
x
that.
to the 7th, and you just subtract them.
No,
Then
I
divide
think you could do
divide by x. So equal 3.
Okay.
That's what I said. Like,
Thoughts. Let's have some thoughts.
I
Okay?
think this.
What are we thinking here? All right? What are we thinking here? Michael?
I think that like for the first question, like for the first two, like we kept on like to like whenever we did like that variable or like exponent, we would divide by 2 easily. So I don't even know that it would work for the thing.
Anybody the exponent's odd? Okay. Okay, that's fine. We might have to look into that a little bit here. Okay? Right?
I think you could do what we did where we had whole numbers where you could do either like x and then multiply by x to the second, but then because you're still adding and it's a multiplication question, you would then equal x to the third or vice versa. You could do like 10x to the 10x to the 10th divided by x to the 7th, and you equal x to the third as well there.
Okay. All right.
Question.
Yes. You could. But the whole idea is to simplify this radical. Okay? Would that help you simplify the radical? This one is radical x cubed. Or x to the
The
third.
radical is the check.
The radical symbol is that symbol. We call the whole expression a radical. Okay? Michael?
I don't even think that I could even do this because I would be here for when we did the whole numbers.
Well, you can still do this. And it works the same as the whole numbers. Okay? Actually, Noah, did you want to add anything to the conversation?
No.
Okay, that's fine. That's fine. Okay? Ryan's actually right on track here with this. Okay? And you actually apply what we did with the numbers to this example. We know, excuse me. We know that if the exponent on our exponent, if our exponent's even, then it's a perfect square, right? We just did that with the previous two examples. Give me a second. There we go. That's not the case here. The case is here that is odd, right? So we know that's not a perfect square value because the exponent's not even. So we got to treat it like we did when we had a number inside the root that's not a perfect square number. Okay? What's the largest perfect square factor of x to the third? Noah? X squared. Right. Okay? Because that becomes x squared times x, right? So this becomes the square root of x squared times x. Then you can split it. And then what's the square root of x squared? X. Final answer, x radical x. Okay? So that's how it gets simplified. All right? So then, how would you simplify the square root of x to the fifth? Then, think about patterns again here. This is all about patterns. All this stuff is patterns. Okay? What do you think, Noah?
Would it be x? Wait, I don't know how to say it, but
That's okay. Talk me through it.
so x radical x squared times radical x.
Very close. You should have stopped where you did. No, that's okay. You're pretty close. You're pretty close. Okay, Michael.
The radical of x to the fourth.
Yep.
X.
The largest perfect square factor of x to the fifth is x to the fourth. Okay. Here's a little clue. The largest perfect square factor of your variable, okay, when it's raised to an odd exponent, is 1 less than the given exponent. Okay. The largest perfect square factor of x cubed was x squared. 1 less than 3 is 2. Okay? So the biggest one here for x to the fifth is 4. 1 less than 5. Okay? What's the largest perfect square factor of x to the seventh? X to the what, class?
6.
Bingo. Okay? And then it's going to be times x every single time. Okay? So the difference between the exponent being even versus the exponent being odd is when the exponent is odd, you have a radical x left over. Mm-hmm.
So it would be like whatever x to the whatever radical x.
When you're doing square roots, yes. When you're doing other roots, you have to be more careful. But we're not going to do other roots here. We're just going to work on square roots. Okay? Okay? So just look for patterns here. Like, for example, the square root of x squared was x. Okay? Well, then the square root of x cubed is x times that remaining radical x. So there's patterns here going on. Okay? So keep that in mind when you do these. Because what we're going to do now is we're going to simplify expressions that contain both a numerical part and a variable part. Okay? Now I'll walk the first one through with you. You guys ready to try one? Right there. Let's go. Okay? It looks intimidating. Okay? But how many times has it looked intimidating and turned out to be not a big deal? 0. Marina, ye of little faith. Okay? I'll tell you what. You guys take care of square root of 50. I'll help you with the variables. You know how to do 50. Take care of the square root of 50. Okay? Maybe a minute here. How you doing up there, Jack? Okay? I feel like you're up there in your own little exile island or something. You doing all right?
You just back a desk at least. No. It's so
I think this is so far the biggest square root we've done.
It might be, but it's not. It's not that. It just follows the pattern of all the others. What's the largest perfect square factor of 50? 25. Okay. 25 times what? 2. Okay. So here's what we're going to do. Let's just write this as a large radical. Okay. Whoops, if I use my pen. So I have the square root, I need a larger one, of 50. I'm sorry, not 50. 25. 25 times 2. Okay. Now, is x squared a perfect square number? That is a perfect square term. Yes. Okay. So we're going to want to keep that as is. Okay. I will in a minute. I didn't know how long to write it. Okay. And then what about y cubed? Yep.
Y times y to the second times y.
That's it. So we're going to take the square root of all of that. Okay.
That's it.
Nope. You guys split it up now.
Is this gonna be on our test?
Mm-hmm.
Okay, well, I'm gonna do horrible.
No, you're not.
Yes, I am.
You're going to practice it. You're going to be okay. All right. Split it up now. It's the same thing. It's the same idea we did on Monday. We're just throwing in a little bit of a variable into it now. That's all. But you don't change your process. Okay. So square root of 25 times the square root of 2 times the square root of x squared times the square root of y squared times the square root of y. Okay?
We have to write all that out.
Well, you have to at least show one of these two steps. Okay? I'm writing it all out so you can see what happens here. Okay? Because what is, hold up, Brian. I want to go through the first one, make sure everybody's good. Okay? What's the square root of 25, everybody? 5. What's the square root of x squared? X. What's the square root of y squared? Okay, so these 3 items will get multiplied on the outside. Okay? And then anything else so under a radical symbol gets multiplied and mashed together on the inside. Okay? So you're going to have to combine these together also. Okay? So everybody see how that works? Your final answer, 5xy square root 2y. Did everybody see how I got that? Okay. All right. So let's talk about this again, okay? Large perfect square factor of 50 is 25. We wrote it as 25 times 2. That's my 50, okay? Everybody good with that? Do I need to highlight it so you can follow along? Okay. So there's 50. There's 25 times 2. That's how I got my 50, right? Okay. So now, x squared. That's a perfect square. It comes right down. Because the square root of x squared is x. All right? We want perfect square factors here. It makes our job a lot easier. Okay? Now, y cubed then, right here, that's y squared times y. The largest perfect square factor of y cubed is y squared. Okay? Now, you're going to take the square root of each individual factor. These are all factors of this radicand. Okay? So you're going to square root each of the factors individually. So you list them all like that. Okay? What is the square root of 25? 5. What is the square root of x squared? X. Yep. What is the square root of y squared? Y. And we can't do that with the square root of 2 and the square root of y because they're already simplified. We can't simplify those any farther. Okay? So to get your final answer, all you have to do then is multiply all of your terms on the outside of radicals together. You get 5xy, and all your terms inside radicals together and get 2y. 5xy, radical 2y. Yep, I'll move. Okay. Should I try another one? Oh, I think we should if you guys still need some practice. Okay, so once again,
It's what you can
All right, let's try the next one here, number 2. Okay. Let's first of all find the largest perfect square factor of 96. 40 is not a perfect square though.
36 of perfect square.
Check it. See if will 36 divide 96? Okay. 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 You want to find the largest perfect square factor of 96. Okay. You can use your calculator to find it.
That's 81. That's 9 times
Are
9.
you serious?
81. No.
No, 81 doesn't divide 96 evenly, Michael. What's the largest perfect square number that divides 96?
32.
32 is not a perfect square, Sophie. Okay. What times itself is 32? Okay. 9 won't divide 96 either, though.
7. I don't think 7 would do
I
it.
think it's
Remember, think about your list of numbers that you are dividing by here. 4, 9, 16, 25, 36, 49, 64. Which of those is the largest perfect square factor that goes into 96?
I think it's 6.
It's 16.
Yeah, it's 16.
Remember, you're going from this list, okay? You're dividing by this list. You're not going to take any numbers that are not perfect squares. So you're going to figure out between 4, 9, 16, 25, 36, etc. Which of those numbers in that list is the largest perfect square number of your radicand? Those are all perfect squares, dear. It's 16. 36 doesn't divide 96, Michael, evenly. 36 times 3 is 108, and 36 times 2 is 72. Okay? It doesn't go in. 16 is the number. 16 times what? That's what we're looking for. Okay? So, this becomes the square root of 16 times 6 times x to what exponent? X to the 4th. Yep. Times x times y to the 6th. Because it's even, it's a perfect square. Okay? Now split it and simplify it. All right, again, I'm going to highlight the radicals that will not get simplified to actual, terms or whatever that stand inside the radical. What's square root of 16? No. What's the square root of 16? What times itself is 16? 4. Okay. Radical 6 stays the same, right? Square root of x to the 4th? Radical x stays the same. Square root of y to the 6th. There you go. Okay. Now, what gets combined on the outside? 4x squared, y to the 3rd, and then these stay on the inside. Radical 6x. And that's it. That could happen, and the reverse could happen as well. It just depends. Okay? Just depends. Okay? Yeah, let you guys try the next one here on your own. See what you guys can come up with, okay? And I can help you as we go along. So if you need some help, don't be afraid to speak up. All right? But you have to practice this. First order business, find the largest what kind of factor of the number? What kind of number are you looking for here? Perfect Perfect square number. You want a perfect square factor of the number. Okay? There's the number. Don't worry about that negative sign right now. I'll help you out with that on when we go back on it together. Just simplify the radical right now. Okay? We're on 45. Okay? You're going to have to use your examples to work through your assignment tomorrow and review for your assessment. I think you guys are capable of doing so. Mm-hmm. Just making an answer real quick. Yeah. Not quite. One thing is off. Okay? So I usually whatever so it'll work. You lost it on the number. Okay? The rest square root. The 15 square factor. Yes. There's your perfect square factor. That's what you need. Okay? You have to make sure that one of your factors when you go to figure out your product for your number is a perfect square. Okay? That's that's key. If you don't have that, this method doesn't work. Those look good, guys. Nice job. Well, is 15 the perfect square number? That's why you're having trouble. Mhm. So there's another possible value there, Miranda, that you gotta find. And where one of those factors is a perfect square number. Noah? Well, you gotta tell me. You only have 3 of them. When you square it squared, you get x to the square, x to the third, or when you get x to the fourth or fifth. When you square this, what do you get? X to the fourth, right? You start out with x to the third. So it's too much. I made that way too complicated.
I did that, and then I just did.
Well, here's the deal. 3 to the square root of x squared. So it's going to square root of x. Just put x. I'm sorry. Yeah. Okay. All right, we're going to meet up here again in just a second. Maybe try to get another one of these accomplished too. Yeah, perfect. Let's take care of your variables. Yeah, you can do that for your number. That's fine. Yeah, you can do that for your number. We need that. Just match what's square root of 9? The radical 5. Pardon me? That's correct. That's correct. Now you gotta take care of your variables. We're gonna work on that together, okay? Michael, what's up, bud? You think you got it? Let's check it and see.
I think I did it wrong.
Okay, well, we're gonna check it and see here. All right, I think we have to flip another one for you guys too. Okay? What's your final answer? All right. Well, yeah, don't worry about the negative sign. I told you to disregard it right now, okay? What's gonna happen is that negative sign is just gonna carry over into your final answer. It's gonna be negative. Okay? That's all. Mash it together. Don't put your multiplication symbols all throughout, okay? That's fine. Okay, so I got 9 times 5, right? What's the largest perfect square factor of x to the third? X.
X squared
Yep.
times x.
Right. And then y to the fourth stays y to the fourth, right? Okay. Split it up. So I have 9, 5, x squared, x, and y to the fourth. Okay? So, question. What is square root of 9?
Square root of 9 is
3.
5. None
Square root of x squared?
is x.
This one stays under, this one stays under. Okay? So 3x, y squared, radical 5x. And then this negative sign right here is this negative sign right there. That's it. Okay? Well, let's take a look at our time. I don't have time to go through another one. So let's go over what your homework assignment looks like. Okay? But these examples here, these are good references when you do this assignment. Okay? So let's pull it up here and take a look at it real fast. The first one anyway. Okay? Sit and use the answer key for help because I work out every single problem on the answer key. Where'd it go? There it is. Okay. All right. So take a look at this. Here's what I want you guys to do for me. Okay. This looks big, but it's not. I've really reduced this. Okay. There's 24 problems on this assignment. You're going to work 8 of them. Yep. That's why I reduced this to only 8. Okay. You're going to select 4 from the top batch. Okay. Then you're going to select 4 from the bottom batch. My suggestion, if you really want a mix of difficulty here, pick a problem from each column. Okay, so pick one of these 3, these. Okay? That's it for that assignment, yeah.
If we want, can we try and finish it off?
What?
If we want, can we try and
Absolutely.
So like do like does like the top row go like the whole top go with first?
That's correct. And the puzzle is optional. You do not have to work the puzzle. Okay? In fact, if you only work 8 problems, you won't have enough to do the puzzle. And that's fine. I'm not worried about the puzzle. I'm worried about the problems. Okay? You have to do 8. I don't care what 8 you pick. 4 from the top, 4 from the bottom. Okay? But I just give that as a suggestion to work one from each like set of 3. Okay?
So we just put the letter in the box.
Yep. But again, I'm not worried about the puzzle. Okay? I'm worried about you getting the problems correct.
We have to show work.
Yes. All right. Always. Okay. And then you have your review for your assessment tomorrow too. All right. Your assessment's only 12 problems. Okay. 6 of those multi-step exponents problems. 4 like the ones we just did for fire up, and then 2 square root problems. Nope, not this time. Okay. All right. It's time to venture on the 6th period. Okay. Yeah, Marina, I'll pull it up again. Here you go. What is it you're wanting to see? Okay, hold on. It's coming. Oh, I lost it. Just a second. I'll pull it up. Or come up here with the pen. Marina. I'm kidding. This thing's very sensitive. Gets his feelings hurt all the time.